Hey everyone. Today we are looking at Dapr and how to do microservice communication with JavaScript. So let me start with sharing my screen. Here we go. All right, so if you're not familiar with Dapr, Dapr is very useful if you are creating microservices because you can actually write your microservice in any language that you're already familiar with. You can use the Dapr API to use many of the built-in Dapr features. So as you can see here, there are many building blocks in Dapr. And today we're looking at service invocation and publish subscribe. What you also get out of the box with Dapr is you get built-in observability, security, and resiliency. We'll also have a look at observability and resiliency in specific a bit later. And you can host anywhere on any cloud or edge. I'll be running the demos from my local machine, from my laptop, but you can host it in any of the big clouds or just on plain Kubernetes. Another nice thing about Dapr is if you use all these different building blocks, all these different features, you're using a unified API, which is decoupled from the underlying resources. So in our case, we are going to look at service-to-service invocation that doesn't rely on any additional resources, but publish subscribe relies on message brokers. And what I'll be using in my demo is I'm using Redis as the message broker because that's what you get when you install the Dapr CLI. So it's the easiest and quickest thing to use. But it's very easy to switch out Redis for another message broker, any one of the big cloud providers or any of the other open source projects. And the only thing you need to do for that is change a component file, which is basically like a YAML configuration with some connection data. But your API, your code, stays exactly the same. And that's what makes Dapr really powerful. All right, so these are the only two slides I have. The rest is all in this GitHub repo. It's all in open source. It's Dapr messaging JS. So I'm going to switch to VS Code now. All right. So I'm going to give two examples, both synchronous messaging using service invocation and asynchronous invocation using PubSub. And the use case will be around a student registration. So you can imagine that a student goes to a website and fills in a form that they want to follow a certain class and they pay for that. So, and that I've simplified that use case to two services. First, we have a registration service, and that accepts a payload with the name of the student, their email, the class that they want to follow, and the cost. And that registration service then calls out to another service, which is the payment service, and that only receives the email and the cost. So let's have a look at the prerequisites if you want to run this yourself. You need to have Docker Desktop installed. You need the Dapr CLI. You need Node.js because we're talking about JavaScript and Node.js microservices in this case. And you need to have an option to actually invoke these services using HTTP. And I'm using VS Code with the REST client, which is a lovely extension. I'll show that to you later. When you just cloned it, you need to install the dependencies of these demo projects. So you can do this with npm run install Mac or Windows. I've already done that. Let me open this sync folder first in the terminal. So synchronous messaging is like an easy way to actually start with your microservice communication. So what happens is, in the case of Dapr, you have a registration service here, which has a Dapr sidecar. And that sidecar will actually communicate with the other sidecar of the service you want to communicate with. So it's not that your registration service is communicating directly with the payment service. No, there are like a couple of more steps involved, as you can see here. So let me take you through it right now. So what happens first is in your registration service, you'll use the Dapr API to invoke a method on the payment service. But the first step is then using the Dapr API. So that's this arrow here. So we're calling out into the Dapr sidecar, and we are providing the name of the service that we want to call. So every service in Dapr has an application ID, an app ID. As you can see here, the registration service has an app ID registration, and the payment service has an app ID of payment. So we are specifying this payment ID in the header of the request that we're making to this Dapr sidecar. Then Dapr looks up what the location is of this payment service based on this app ID. So that's this name resolution part. Then the location is known, and then Dapr will make a request to that other Dapr sidecar. Then the sidecar will actually forward the request to the actual payment service, and then your code can do something with the request and handle the payment. And then the same sequence follows back. And so your payment service posts back to the Dapr sidecar, and the Dapr sidecar talks to the other Dapr sidecar, and then the registration service receives the response. So there's quite some steps involved there. Some people are worried about latency. Usually latency with sidecars is really measured in milliseconds. So I think on average, like 4 to 5 milliseconds is normal. So there is not a lot of additional latency involved. And yeah, you're probably not the most worried about latency if you're using JavaScript anyway, I think. Okay, so this is the whole process. Now let's have a look at the code, and then let's run the sample. So if I open up this sync folder here, there are like 2 subfolders, one for the registration service and one for the payment service. So if you have a look at the registration first. So first I have open up the package.json file so you can see what kind of dependencies we're using. So in this case, we're only using Express. So we're not introducing anything Dapr specific. There is a Dapr JavaScript SDK that you can use, but it's optional because Dapr works fine with just making plain HTTP or gRPC calls, which we're doing in this case. So if you have a look at the content of the registration service, since we need to talk to Dapr, to the Dapr sidecar, we need to specify where the Dapr sidecar is and which port we're using. So those are these constants. This is the regular usage of Express. And then here we have a registration endpoint, which accepts a post. And whenever we call that, then we log a message that the registration is received. We specify the payment data that we will send to the payment service. So in this case, it's only the email and the cost that we're extracting from the body. And then we do a post to the Dapr sidecar, and we do it to the payment endpoint, and this endpoint lives in the payment service. So I'll show you that in a second. So we do a post, we provide the payment data and the body, and we specify 2 headers, the content type, and this is the most important one. We specify the name, the application ID of the service that we want to talk to in the Dapr app ID header. And so this is the way that Dapr can figure out where to send a message to. All right, so that's the registration one. So if you look at the payment service, again, if you look at the package.json file, we only have Express as a dependency. And if you look at the body itself, it's very minimal. Again, we are using Express as the framework. And here we have the /payment endpoint that's accepting a post. And we just simply do like a console log and then send back the body of the request. So nothing much going on here. It's just a very, very basic example. All right. Now let me switch back to the README. All right. So there are 2 ways how you can run this sample. So if you're running on macOS or Linux, you can use a Dapr multi-app run, which is super useful because you only need to run 1 command in order to start up multiple services. Now, in this case, I'm running on Windows. Multi-app run is not yet available in Dapr 1.11, which I'm running. Dapr 1.12 will have multi-app run support, so that's great, and it will be released very soon. So very soon I can also use this. But now I have to start the services individually, so I'm going to do that. So I need to change to the registration folder and into the payment folder. I can collapse this for the moment. So now I'm going to start both services. So this is the instruction to start the payment service. So I'm using the Dapr CLI. So I'm instructing the CLI to run this application on a certain application port. Every application needs an ID, which I already mentioned. And we are specifying the HTTP protocol for communication. And this is the Dapr HTTP port that I'll be using. And the application itself will be started by running npm start. So it's quite a long command, but this is how it's constructed. So this is for the payment. So I'm starting that here. All right, so that's starting up. And if I scroll up a bit, we can see that payment service listening on port 5502. So that's just waiting for us. Perfect. And we're going to do the same for the registration one. So that's this one. And the only thing here is just different ports, so things don't clash. And of course, a unique application ID here as well. All right, and here we also saw the message that registration service listening on port 5501. So now both services are up and running, so now we can invoke it. I told you I'm using the REST client in VS Code, and this is the REST client I'm using. And that allows me to have these .http files. And in the HTTP files, I can specify variables and then do stuff like this. I want to do a post to a combination of these variables. It's localhost and in this case, the registration port of the registration service. And then /register is the endpoint I want to invoke the message to. And then I specify a body here. So yeah, I like this extension because it allows me to add these HTTP files directly in my Git repo next to the service. So there's also this send request button now. So if I click that, then I'll invoke this endpoint, and then the result will be shown to the right. So I'll make some space for that. And then we will also see some log messages in here that you're actually calling out to both services. So on the left-hand side is the registration services, and on the right-hand side is the payment service. Yes, I'm going to invoke it. All right, and we get a 200 OK back from the registration service. And we see in the logging that the registration is received and also that the payment service has also been called and that the payment has been received. All right. So this is the first demo done. The easiest one of them all. Well, okay, now I can close this and close this. Right, so this was like a typical happy flow, but of course, happy flow is often used, but there are always deviations. So the nice thing about Dapr is that resiliency is also built in and is also configurable. So in case you have some network errors or one of these services is temporarily down, then you can make sure that Dapr does some retries to make sure that you actually can make the call. So we can have a look into that now as well. So in this folder, there's also in the sync folder, there's also a resources folder, and that contains a resiliency YAML file. So let's have a look at that resiliency file. Again, it's a YAML configuration file, which has a unique name. In this case, it's scoped for the registration service. And there are different policies defined in this resiliency file. So there's one retry, which is named retry forever. And this is a retry policy that is like constant, and it will be taking 5-second pauses before it will retry again. And it will retry indefinitely because max retries is -1. So if a call fails, then it will wait 5 seconds and then it will retry again. And if it's still failing, then it will wait for 5 seconds and it will retry again, and so on. There's also a circuit breaker policy defined as well, called simple CB for circuit breaker. And this will open when there are like 5 consecutive failures of calls, and then it will time out for 5 seconds. And it will just make one request to actually check, okay, is this server still having issues? and if so, it will time out again. The final part is how you actually apply these policies. So in this case, the target of the policies are in this case apps, and we are applying this to the payment application because the registration service is calling the payment service. So that's our target, and we apply the retry forever policy as a retry and the simple CV as the circuit breaker. Right. So what I'm going to do now to sort of simulate that there's an issue with the payment service, I'm just going to stop this payment service. So that's now stopped. I'm also going to stop the registration service because I actually need to restart that by specifying the resources path. Because the first time I called it, I didn't include any resources path, but now I am including that. So Dapr will actually load in this resiliency configuration. So I'm copying this. So now the registration service will use this resiliency configuration. It's up and running for us again here. It's awaiting. The payment service is down. So if I run the same command again, I'm again making a post to this register endpoint, then yeah, we should see something here that indicates that this service is not available. So let's see. All right, so now we see here error processing operation endpoint, and we also see here retrying in 5 seconds. So now the retry policy is already kicking in. So what I can do now is, let's say this was like a temporary issue, so I can start up this payment service again. All right, which is here. And now it should soon complete. Yeah, and now the payment is received, and we get back a 200K from the registration service. So that's one of the nice things about Dapr is the ability to have these resiliency policies, which you can apply or scope very specifically for certain applications or apply globally across all kinds of services. And you don't have to change any code for that. All right. So that concludes the part about the synchronous messaging. So let's move on to asynchronous messaging now. So asynchronous messaging is really useful if your backend process takes a very long time, and you don't want your user to wait for that. So in this case, it's just one service communicating to another service, which might be very quick, but maybe it kicks off a very long running process, which could take minutes, and you don't want your user to wait for that. So in that case, you should look more into like event-driven architectures, where you're communicating between services with messages. Another nice thing about that is you can also trigger different services with one message. So what we see here is we have the registration service that now communicates with a message broker at a certain topic, and another service is subscribed to that topic. And as soon as a message is put on a topic, the payment service is then triggered to handle it. But it's more than just one payment service. So we can also add multiple services here, which all listen to the same topic. So that makes PubSub very versatile. It's also very nice that this registration service doesn't need to know anything about any other services, right? So in case of PubSub, we are not specifying anything here about that it needs to call a payment service, which in the synchronous way, the service-to-service verification, there you need to have a reference to this payment service in your code here, because that's what's required in the header. So this is like very loosely coupled, great for event-driven systems. And what happens here, since we're still using Dapr, your registration service will use the Dapr PubSub API. So you're first sending a message to the Dapr sidecar. Dapr then figures out, based on a component file, what the underlying message broker is. In this case, it's Redis. So it will forward the message to Redis, to a topic on Redis. And then the receiving end is then subscribed to that topic. So the Dapr sidecar of the receiving service is subscribed to a topic. So that is the one that gets the message, and then the Dapr sidecar will forward the message to the actual payment service so you can handle it. Okay, I'm gonna stop these applications because we need to switch out to a different folder now. So now I'm looking at the async examples. So let's open that. And again, I'm going to the registration folder and the payment folder. All right. So again, if you're running on Mac and Linux, you can start this now with just one command, Dapr run f. I actually didn't show you how this works. So if you're using multi-app run and do Dapr run f and start that in the async folder, then it loads this dapr.yaml file. And in this file, you actually specify what applications you want to run, where they are located, what ports you want to use, and how they are running. So the commands that you're running. So this contains the same information as I was just using in the plain Dapr CLI commands, but now it's all in one place. So this is what you're starting at. All right, but in my case, I am running these commands. So this one starts the payment service. So what is different about it now? Not so much. The only thing that we already are using is the reference to the resources path, because both services need to know that we are using a message broker, and that message broker is configured here. So I'll run them first. I'll start them, and then we have a look in the application and also in the resources. So this is the payment. Right, and this is the registration. All right, so those are up and running. Now let's have a look at the code and the resource. So let's start again at the registration. So again, I'll show you the package JSON, and I'm only have a dependency on Express. So this is the content of the registration service. So again, we need to communicate with the Dapr sidecar. So there's the host involved and the Dapr port. In this case, Dapr also needs to know what kind of component we're using, and that's done by name. So we are using a component name, and the name of the component is student PubSub. And I'll show you in a second what this name matches up to in this component file. And then we need to specify a topic that we're publishing the messages to. Then there's the regular Express configuration again. Again, we have a register endpoint, so this is still the same. Again, we do some logging to the console that the registration message is received. Again, we have the same payment data. But then on this line here is the difference, because we're now making a post call to the publish endpoint. So this is the Dapr host, the ports, and then we're using v1 of the publish endpoint, and that also needs then the PubSub component name and then the topic. So that's the entire URL. So we are posting to that, and we are providing this body, and that's all what's happening here. There's nothing else happening here. Okay, so how does Dapr know what the underlying component is, the underlying PubSub component? Well, it's loading this YAML file, this PubSub YAML file. There are more YAML files, but I'll come back to that later. They're not used at all now. So here you can see that the metadata name, student PubSub. So this is what was used in the code. So this is the thing that we are calling out to. So Dapr knows that as soon as I'm making a call to the publish endpoint that contains this component name, and then it needs to load this configuration in order to communicate with the underlying message broker, which in this case Redis. All right, so that was the registration one. So that is the service that is publishing. So now let's have a look at the service that is subscribed to the same topic. Again, have a look at the package JSON. I'm only dependent on Express, and this is the body of the service itself. Again, we need to specify that we're listening to a certain component and a certain topic. We're using Express again. What is a bit different now is the way that we are parsing our body, because what we are accepting or we subscribe to, those are cloud events. So that's why this is a bit different with this asterisk in here. Now, there are actually two ways to subscribe to topics. This is the code way. So now I'm subscribing using JavaScript code. I will show you the declarative way using YAML later. But here you can see we have a get endpoint to Dapr/subscribe. And here you see that I'm configuring what is the name of the PubSub component, what's the topic. And as soon as we receive a message, then we want to forward that to the pay endpoint. So that's what this route is. This is then the pay endpoint that accepts post requests. I do some logging that we are receiving some data, and then I do a quick check on the payload. I check if the email is empty. If it is, then I send like a bad request. Otherwise, I send like a 2 or 4. I'll come back to the bottom, just like a different function. Okay, so let's try this out first. So both servers are already running. So now I can make a request using the local async test HTTP file now. The structure is entirely the same. I'm just using some different ports. And the payload is also the same. So I'm now expecting the same thing to happen. I expect 2 log messages here that both servers are being called, but now we're actually using Redis as the message broker in between. And I get back at 200 OK, registration received. And indeed, we have both services do a log to the console that this service is called, and also the payment service is called. So this was the happy flow again. Right. Yeah, I almost forgot about this. I forgot about the observability part. So let's have a quick look at Zipkin. Because if you go to Zipkin and, for instance, check the dependencies, you can actually see the services there. Can I zoom in on this? Not that much. So this is the registration service, and this is the payment service. And here you can actually see all of the requests that are going on. So you can actually visualize all of the services and how they are communicating with each other. And this is what you get out of the box, which is pretty cool. And you can actually dive a bit deeper, and then look into the calls and the call chain. And so we start with the registration service, and then we end up with the payment. Yeah, and this is for the PubSub messaging, right? So we're using the student PubSub component here, and the topic was new students. All right. Okay, we have done this. So now actually let's change the way how we do subscriptions. So let's stop this. So we've seen the code way to do subscriptions, but we can also do subscriptions declaratively. So here you see a subscription. Now it's a ._ YAML file, but let me remove the underscore. So next time it will actually be used. So you can see it's a configuration is of kind subscription. It needs a name. Then we have the specification of the topic, which is new students, and then the route again, which is /pay, and the name of the PubSub component. Optionally, you can also specify a dead letter topic, which requires its own configuration. Let's first do the declarative way, and then I'll look into the dead letter one. So if we use this subscription YAML, we don't have to do the subscription in code. So we can actually get rid of this part. So let me put this in comments. And then we also don't know, we don't need to know in our code the name of the component and the name of the topic. And so if you want to be as light as possible regarding your code, that your code doesn't know anything about Dapr, then I think it's useful that you do the declarative subscription using these subscription files. All right. So this should be good. I can now start these again. And I can start this one again. Okay, so both services are up and running, and we now expect the same behavior again, because we only changed the way how the subscription is configured, either via code or via YAML, but we didn't change any behavior. So if you do the same test, now both apps are still triggered, so everything still works as expected. So this is the happy path again, which is good. Okay, let me stop this again. Okay, so now let's move on to using an actual dead letter topic. So dead letter topics are used when a message can actually not be delivered to the subscriber, or the subscriber can't really process the message. Then you can instruct Dapr to put that message on a dead letter topic, and you can either then inspect them manually on that topic, but you can also specify another method to actually handle these dead letter messages. So that's what we are going to do now. So you already saw that in the subscription YAML, I specified a dead letter topic. It's called dead letter messages. And now we can also use this dead letter configuration. So again, it's a kind of subscription again, but in this case, the topic is dead letter messages, and then the route is in this case /invalid, which is the function I very briefly showed here. So when we receive something that we can't process, it will be posted to this invalid endpoint via the dead letter topic. And then we log to the console that we receive an invalid message. All right, so let's do that now. Again, let's start both of them. And let's first still do the happy path to see that we didn't break anything. Again, I need my examples here. So now we just trigger a valid message again. Everything is still up and running. So now let's do this. Everything is still fine. But if I remove the email, which was actually a check in the payment service. So now this payload is actually seen as invalid. So then we get a bad request. So that should trigger then the message to be placed on the letter topic, and that should then trigger the invalid endpoint. So now let's test this. Yeah, and now we see that invalid message received. The email is empty. So that's working as well. All right, let's take it one step further. Let's close this and close this. So the final step wouldn't be like combining resiliency and dead lettering, because we saw resiliency also in the servicification sample, but you can do the same type of resiliency when you're interacting with components. So this is a resiliency configuration. Let me first rename it. That has something similar. We specify a retry policy. In this case, the name is pops up retry, which is a constant policy. So in case something fails, we wait 3 seconds and then we try again. But in this case, we have a max of 3 retries. And in this case, the target is not another service, but in this case, the target is a component, which is our student pops up component. And this is triggered on the or target on the inbound, and then we do the pops up retry. So what will happen now if we do this again is that in case we have a bad request, so the email is missing, so the resiliency policy will kick in. It will retry for 3 times, but of course it will also fail 3 times because there's something wrong with the request. And then it will be placed on the that letter topic, which then triggers the invalid endpoint. So let's do that. Okay, so this is the empty one. So we do send request. And we still get back at 200K because this is an async process. So it's completed from the registration side. But here we see bad request. Status code return is 400, and we got like a couple of those. And then finally, it ends up being posted to the /invalid endpoint. All right. So that was a combination of two different ways of doing the subscription code-wise and declaratively using YAML. Then introducing the lettering, and then also introducing a bit of resiliency as well. Let's briefly go back to Zipkin and let's run the query, because here we see that we have like the failed one here, so we can actually inspect what's happening here. So we called the registration endpoint with the missing email one. So it was picked up by the payment, which it couldn't handle, and then it was retried like 3 times, so 1, 2, 3, and then it was sent to the dead letter messages. So that's how you can see the flow, what's happening here. All right, so those were all the demos. As I mentioned, everything is open source. So if you want to try this for yourself, go to dive/Dapr messaging.js. So you can all run it yourself. If you want more samples, or you want to, for instance, see how you can use the JavaScript SDK, I can definitely recommend you to look at the Dapr quick starts. Because, for instance, if you look at the sub samples in the Dapr quick starts and go to JavaScript and go to SDK, because I've shown you the plain HTTP calls, but here you can see how the JavaScript SDK is used. And so we create a Dapr client, and then we can actually use client.popsub.publish. So the SDK is a bit easier to use than the plain HTTP commands. And last but not least, if you have any questions, definitely recommend you to go to the Dapr Discord. There are a lot of channels there. There are channels for all of the different repos. There are channels for all of the different APIs, for all of the building blocks. So it's definitely a good resource to get some more help. Thank you very much, and I'd like to see you at the next webinar.